section of a plane and a double napped cone. If you remember the handout I gave you yesterday, that big packet that was just informational, it had the 4 pictures there. This produces 4 conics: the circle, which we did yesterday, the parabola, which is what we're going to do today and the next school day, then the ellipse and the hyperbola. So we're going to do the parabola today. A parabola is the set of all points x comma y that are equidistant from a fixed line called a directrix, and a fixed point called a focus not on the line. The midpoint between the focus and the directrix is called the vertex, and the line passing through the focus and the vertex is called the axis of symmetry of the parabola. So if you think back to Algebra 1 and Algebra 2, we've talked about a parabola, and we talked about a vertex and the axis of symmetry. But now that you're in pre-calculus, we're going to now look at the focus and the directrix. And we're not only going to do up and down parabolas, we're now going to formally define left and right parabolas. Okay? And something I need to point out to you is that the focus is the same distance from the vertex as the vertex to this directrix. So parabolic reflectors have cross sections that are parabolas. Incoming sound, light, or other energy that arrives at a parabolic reflector parallel to the axis of symmetry is directed to the focus. Similarly, energy that is emitted from the focus of a parabolic reflector and then strikes the reflector is directed parallel to the axis of symmetry. So our goal is just to get the foundation of the mathematics. Those applications are college level and usually engineering. Now I will tell you that my son Andrew finished his 2nd semester of physics, and they did a lot of work with mirrors and real images, virtual images, and he kept drawing as he was studying. He's like, "Can I explain it to you, Mom? You know, it'll help me study." And he kept explaining it to me, and I didn't always understand everything he was sharing with me, but I listened. So it's pretty advanced stuff. So again, the good news is we're going to do the basics, and today we're going to be very, very basic, where our parabola will have the vertex at the origin. On Monday, we're going to take it off the origin. So I'm doing this nice and slowly to ease into this. So if we have x squared, and this is a different form than what you've seen in Algebra 1 and Algebra 2. If I have x squared equals 4py, the focus is p units from the vertex. The directrix, and I actually don't want you to memorize any of this stuff over here. You do need to know the equation. Now, if it's x squared, we know it's going to open up or open down. And go ahead and draw this for me. Here's the vertex. The focus is p units above the vertex. And then we're going to have this line called the directrix, and it's p units from the vertex. So the vertex is in the middle between the focus and the directrix. And what I want to focus on, pun intended, is...
Excuse me, can I see Katie?
Sure.
For a moment, please?
Yeah. What I want to focus on is analyzing and thinking about it, because once we take it off the vertex at the origin, then you're not going to have any problems, and we don't need to memorize any crazy formulas. Now, if it opens left or right, let's look at the case where it opens to the right. If this is my vertex, the focus is p units inside it, and then the directrix is p units from the vertex. Okay, so we're going to need to keep that straight. So let's look at example 1. It says graph x equals negative 1/8 y squared. Now, if there's a y squared, what type of parabola is this? Up, down, or left, right? It's a left, right. And so you want to look right above, and the formula for a left-right needs to be y squared equals 4px. Well, our equation doesn't look like that, does it? We need to, in fact, multiply by a negative 8, and I would get negative 8x equals y squared. So negative 8 should be spitting out the same value as 4p. Do you see that? Because the y squareds are the same and the x is the same. So what's in front of the x has to be equal. So I divide by 4, and p is negative 2. So the vertex is 0, 0 because of the form it's given in. And on Monday, you'll see what I mean by taking the vertex off the origin. But let's go ahead and we'll plot the vertex. That's 0, 0. Now we also said because it's a y squared, it either opens up or it opens down. Since p is negative, this is going, oh, did I just say that wrong?
Yeah.
Thank you. Yeah, we said it opens right or left.
She's changing our words.
Yes. Okay. Because the p is negative, it's going to open to the left. So what that's telling me is if it opens left, the focus is p units inside the parabola. If p is 2, and in this case it's actually negative 2, my focus is negative 2, 0. The Directrix is 2 units going the other way, but it's a line, and it's actually, in this case, a vertical line. So the Directrix is x equals 2. Now, if you look at the chart we have on the previous screen, we really are doing p, 0 and x equals the opposite of p. I mean, we are doing it, but I think it's easier to just reason it out. Now, we need to do one more thing. We need to get a pair of points so that we know how wide or narrow the parabola opens. So, and it doesn't matter if I choose that, let's choose, I don't want to do negative 2. I'm at negative x equals y squared. Well, I guess I could do negative 2. All right, if I plug in that x is negative 2, and do you see why I chose that? Because 16 is a perfect square. Y is plus or minus 4. So I can go negative 2 and go up 4 and plot a point. And I can go down 4. And so here's my parabola. So you're going to plot your vertex in just one other pair of points. All right, the axis of symmetry. The axis of symmetry is horizontal. An axis of symmetry goes through the focus and the vertex. So that would be y equals 0. So let's double check our work. I have the vertex, the focus, the directrix, and the axis of symmetry. Okay? All right, let's do another one. Example 2 says graph y squared equals negative 6x. Because it's y squared, it opens right or left. And I need it to be of the form y squared equals 4px. So I then know that 4p equals negative 6 and p equals negative 3 halves. So because it's y squared, I know left or right, but because p is negative, which way does it open? Left. So this is going to open to the left. The vertex is 0, 0. So here's the vertex, 0, 0. Now the focus, since it opens left, the focus is inside, p units away. So I need to go 1 1/2 inside. So that's at negative 3 halves, 0. Then that means the directrix is p units on the other side of the vertex. Since it's vertical, it's x equals, and that would be positive 3 halves. The axis of symmetry will be y equals 0, and then let's come up with a point. Oh, what do you guys want to choose? Any ideas? Y squared equals negative 6x. I mean, if I do 1, well, I can't do 1 because it's coming over here, right? So I need, well, I heard it, negative 6, right? Ooh, that's a good number. If I do negative 6, then y is plus or minus 6. Nice choice. So let's go 1, 2, 3, 4, 5, 6. X is negative 6, and it's up 6. And from there down 6. Nice job. So that one's pretty wide open. Now let's double check our work. I identified the vertex, the focus, the directrix, the axis of symmetry. It happens to be the x-axis there. Okay? All right, let's try example 3. Graph x squared equals 2y. Does this open up, down, left, or right? Up. Good job. This is going to open up. So I need x squared equals 4xy. Oh, gee whiz. Sorry about that, guys. Equals 4py. And I have x squared equals 2y. So 4p equals 2. So p is 1/2. My vertex is 0, 0, but it's going to open up. If it opens up, the focus is inside the parabola, and it'll be up 1/2 of a unit. So that's teeny tiny. So the focus is 0, 1/2. My directrix is 1/2 a unit away from the vertex on the other side. So the directrix would be what? Does anybody want to try it? What's the equation?
Put it on your desk.
Y equals -1/2.
Good job. Y equals -1/2. The axis of symmetry is going to end up being, since it opens up through the focus and the vertex, that's x equals 0. Then let's get 1 point. X squared equals 2y. How about doing y is 2? If y is 2, then x is plus or minus 2. So that's 2, 2 and -2, 2. All right, let's double check our work. I have the vertex, the focus, the directrix, and the axis of symmetry. Please make sure you're using capital F on your graph, a capital V, and you're making, you're a dashed. Because technically there is no line, there is no horizontal or vertical line to it, but it's this special piece of the graph. All right, go ahead and try example 4 the whole way through on your own. Let's see if you can do it. Alright, how does this one open? Up, down, left, or right?
Down.
This is going to open down. The vertex is 0, 0. And so, again, I want you to stay away from trying to memorize that p comma 0 or negative p comma 0 or x equals negative p. If we can do it this way where you're like, okay, the focus is p units, you're going to be able to do Monday's work very, very easily. It'll be beautiful. So here's the vertex. It's going to open down, and so the focus is below, and it's at 0, negative 3 halves. The Directrix would be at x equal, no, sorry, y equals 3 halves. The axis of symmetry would be x is 0. And then what point did you guys do? Did you use 6 again? Okay. Or negative 6. So x squared is negative 6 times negative 6. So x is plus or minus 6. 1, 2, 3, 4, 5, 6. And do you guys notice that we plugged in for the y value and solved for x? You're allowed to do that when you're graphing, okay? So that one's a pretty wide one. All right, any questions on the first 4? All right, pretty straightforward. Okay. In example 5, it says write the equation of the parabola with vertex 0, 0 and directrix y equals negative 3 halves. All right, so what I need to do when I'm figuring these out is I need to plot the information. If the vertex is here and my directrix is below and it's y equals negative 3 halves, that tells me the focus is at 0, 3 halves, and without even doing much more than that, this is a parabola that opens up. And that tells me that it's x squared equals 4py, and p is the distance from the vertex to the focus. If it opens up, it's a positive p. If it opens down, it's a negative p. That's simple. So this is x squared equals 6y. All right, try the next 3 on your own. All right, just to make sure we're on the right track. Did you get x squared equals negative 8y? Yes, good. Because it opens down, p has to be negative. Now the focus is inside the parabola, okay? So this one opens up. For example 7, do you get x squared equals 12y? Yes? All right, last one. Remember, the focus is inside the vertex, so this is opening left. So that means that P is negative, and it's 2 units, so it's y squared equals negative 8x. Okay? Any questions on this? All right, fantastic.